All right, this is going to be the second video for Notes 48, and we're going to do what are called systems of linear inequalities. So when you have a linear inequality, you graph the boundary line, right? Something maybe like this, I don't know, whatever it is, and you shade above or below it. And so here's the thing. We're going to graph two of these together, and we're going to look for where the shading of this inequality overlaps the shading of this inequality. That overlapped shading is the overall answer to the system. There's no one point. There's going to be a whole bunch of points that are shaded in, hopefully, that will fill in and solve this system of equations. So we're going to do the first one, and I'm going to do a boundary here. Y equals 3x minus 4. Remember, that's over 1. So let's see. 1, 2, 3, negative 4. So up 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1, good enough. Okay, then for the inequality here, that is going to be a solid boundary line, which means I'm going to play connect the dots as straight line as I can. That was a horrible straight line, so I'll slide it over here. Yeah, that's better. It actually needs to go through the points. All right, so solid boundary line, and are we going to shade above or below? Now, this says less than, so that means we want to shade below. All right, so where your boundary line is here, you want to shade below. Now, I'm going to do a little color theory here the best I can. So I'm going to pick to go pink for this shading. And then that part is now done. So that is the information for this. Whoops, I'm trying to do a little dot here. That inequality. Now, separately, I'm going to do, whoops, I don't know what's going on there. We'll do blue for the other one. So let's do a boundary line here. Y is greater than negative 2x plus 5. That's going to be over 1 again. So this time I'm going to go to positive 5 on the y-axis. 1, 2, 3, 4, positive 5. And then I'm going to count my slope. That's going to be down to right 1. So down to right 1. And I'm going to keep counting that out. Yes, this is where you're going to notice, right, we're overlapping things. Okay. So for this, I just realized I wrote the boundary line with an inequality. It's fine. Okay, so then for this inequality, we're going to have a dotted boundary line or dashed boundary line. So when I go to play connect the dots, I want to use dotted lines. Okay, so that's dotted or dashed. And then am I going to shade above or below? So my inequality here is greater than, so that means I'm going to be shading, oops, above. So from my boundary line here, I want to be shading above that boundary line. So let me go ahead and grab my blue little highlighter here. Highlight, highlight, highlight. Okay. So here's the thing. We have this section shaded in pink. We have this section shaded in blue. The solution to the system is where we have blue and pink. So this chunk right here, that would be basically, when you look at the color theory, the purple stuff. Okay, then I'm going to kind of overlap that and make sure that we really see that. All right, so it's this section, kind of darkening it out. Now, if you are doing these with paper pencil, make sure that you can see where the overlap is, so you don't overshade either of the two original sections, all right? And you can really see then where the overlap is. Now, if you are working with colored pencils or, you can work with your own color theory, that works too. All right, so that's problem number 4. Let's slide on over to problem number 5 and do the exact same thing. All right, so first, let's go, I'll do red and blue again. So first boundary line, let's do y equals 3 halves x minus 2. So starting off at negative 2, up 3, 1, 2, 3, over to the right 2. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. All right, so boundary line, that's going to be solid. Whoops, right with a pen. Right with a pen. All right, this is going to be a solid boundary line. Let's see if I can draw this one even a little bit better than the last one. Oh, that's not too bad. I'm okay with that line. All right. So that got snapped straight then. And because our inequality is greater than, we are going to shade above. So find your boundary line, pick your pretty color of choice here, and let's go ahead and shade above it. All right, so y is greater than or equal to 3 halves x minus 2. Looks like this. We're going to do the other line. So y equals negative 2/3 x plus 4. We can start definitely with positive 4. So 1, 2, 3, 4. And here's the thing. You'll notice that when the slope was originally written, the negative was in front of the fraction. And when I rewrote it, I tend to put the negative with the numerator. It doesn't matter if you put it with the numerator or you put it with the denominator. Just please do not put it with both. Okay, that's the one thing to be careful about. So our slope here, I'm going to go down 2 and then to the right, 1, 2, 3 spaces, down 2, 1, 2, 3 to the right. Or let's say you did do this and you kept the negative with the 3 and you left the 2 to be positive. Okay, so from your original y-intercept, we would count up 2 and then to the left 3. Up to 1, 2, 3 to the left, okay? Notice that these points are still creating a line. Now for our boundary line for this one, our inequality is strictly greater than. So this is going to be a dotted or a dashed line. So make it obvious that it is dotted or dashed out, okay? And then for our shading, we're dealing with greater than here, so we are going to shade above. So from that pretty little blue line, let me go find my blue again. So shade above, 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 above. And hopefully you can see right here in this chunk where you have both the pink shading from the red line and you have the blue shading from the blue line. So again, I'm going to go ahead and just kind of overlap the shading so you can see it, meaning highlight the shading just a little bit. All right, so it's this chunk right in here. So all of these values, any ordered pair in here would make this inequality true and would also make that inequality true. All right, I'm going to go ahead and close the video out because that's the end of this note sheet. As always, if you have any questions or concerns, please let me know, and I'll see you in the next one.